All right, hello everybody. This is going to be the tutorial video for section 11.1, day 1. So we're starting our unit on probability and statistics, which really deals a lot with analyzing data and looking at the chances of an event happening. So a way that we introduce ourselves into that field of study is by talking about what is called the counting principle, which is not quite the same as just doing 1, 2, 3, 4, 5. That's counting, right? Okay. I do bad jokes even on video. LOL. Okay, so this is kind of a motivational problem to show you how the counting principle works. So let's say that you're going to a restaurant, could be wherever you want, and you have to pick a meal. And the restaurant has choices for soup, it has choices for salad, and it has choices for your entree. Okay, so you get to pick one of each. You get to pick one soup, one salad, one entree. And what we want to figure out is how many different possible meal combinations can you have if you pick one soup, one entree, and one salad. There's two ways you could figure this out. I'm going to show you the longer way of doing it first, where you list out all of your possible options. And then I'm going to show you a shorter way, which relies on this counting principle that is the title of the section. So first way is to make what's called the tree diagram, which really, this is the long way of doing it, but it really guarantees that you see every possible option. What a tree diagram does is it allows you to list all the possible outcomes for an event, which in this case would be your meal. So I'm just going to label here. Oh, Microsoft Word is doing its lag. The event in this case would be your meal combo. So one soup, one salad, one entree. So first thing we do, let's go in order. First thing we're going to order is soup. So all I'm going to do is I'm just going to label and I'm going to pick, we'll do red for soup. We'll do green for salad, and then I'll do blue for entree, just so you can see the different pieces of the tree. For the soup options, all I'm going to do is I'm just going to label the two different types of soups I can have, chicken noodle and tomato. So I'm just going to call one of them CN for chicken noodle and one of them T for tomato. And give yourself some space, because the reason it's called a tree diagram is we're going to have some branches coming off of each of those soup options to get us to the next part for salad. Okay, so assuming that you pick chicken noodle, the next thing we're going to do is we're going to go to salad. What are your salad options? You could have Caesar or you can have chopped. So I'm actually going to write out those full words. So I'm going to draw a little branch, like a tree branch, coming off of chicken noodle. And this tells me my two salad options I could have picked if I picked chicken noodle soup, Caesar or chopped. But I've also got to do it for the tomato soup, because maybe I picked tomato soup the first time. If I pick tomato soup, I still can pick Caesar or chopped salad second round. Now we go to our third round. This is where you get to pick your entree. And I said I'll do this in blue. So you can either do steak, chicken, or vegetarian. So I'm going to use S, C, and V. Well, you got to do every possible branch. Maybe it was chicken noodle and Caesar, in which case now you have three branches coming off of Caesar. Steak, what were my other ones? Chicken or veggie. Maybe you would pick chopped salad. Steak, chicken, veggie. But wait a second. Got to also include the tomato branch. Maybe we had tomato and Caesar salad. Now we got to consider steak, chicken, or veggie for that branch. Maybe we had tomato and chopped salad. We still got to consider steak, chicken, and veggie. So you can see kind of why it's called a tree diagram. It's got a lot of little tree branches. And all we do to figure out how many possible meals are there is we count up all the possible branches from left to right. So I'm going to count them up slowly. Here's one, chicken noodle, Caesar, and steak. Branch number 2 would go chicken noodle, Caesar, and then go to the middle row, chicken. Third one would be chicken noodle, Caesar, and veggie. So that's, I'm just going to label these a little bit at a time. That's 3 possible meals right there. But then we could do it 3 more times with the middle option here. So chicken noodle, chopped salad, steak. Chicken noodle, chopped salad, chicken. Chicken noodle, chopped salad, veggie. Boom, there's another 3 options. And then the same thing would happen for the tomato. Tomato, Caesar, steak. Tomato, Caesar, chicken. Tomato, Caesar, veggie. Another 3. And then our final 3 would be tomato, chopped steak. Tomato, chopped salad, chicken. Tomato, chopped salad, veggie. So I get, add them up, 3 plus 3 plus 3 plus 3 gives me a total of 12 possible meals that I could select if I had one salad, one soup, and one entree. It is a little annoying because you got to sketch everything out. It's not super hard to make, but But the easier way of doing this, or the shorter way of doing this, is to use what's called the fundamental principle of counting, which basically says this. If you have some event M, which can occur in M ways, and you have another event N that it can occur in N ways, then event M followed by event N can occur in M times N possible ways. So we're multiplying the amount of categories we have for every single possible option. So I'll show you how that applies to the example up top. We want to know how many possible meals there are. And there were 3 categories that I was interested in. So I'm going to give them, what I usually do is like little fill in the blanks. I've got my salad, or I guess what came first? Soup or salad? We had soup first, so I'm going to do soup first. We had soup, salad, and entree. And if I want to know how many different meal options are there if I pick 1 soup, 1 salad, and 1 entree, all I need to do is figure out how many soups I have, how many salads I have, and how many entrees I have, and multiply the amount of each category together. So if I go in order, I had 2 soups I could have picked from. I had chicken noodle and I had tomato. So 2 possible options in that category. Times, as it says, we're multiplying. If I go to my salad category, let's go back and take a look. We had, how many salads did we have? We had 2 salads. We had Caesar and we had chopped. So I'm going to put a 2 on this blank. Times, got 1 more category. We got the entree, and this had 3, I believe. We had steak, chicken, and vegetarian. So I'm going to put the number of options in that category, 3. And then all I got to do to use the counting principle is multiply them together. 2 times 2 is 4, times 3 is 12 possible meals. Exact same answer that we got when we made the tree diagram. So there's 2 possible ways you could be expected to answer it. Generally, the counting principle is going to take a lot less time. So that's how we're going to do most of the problems. So let's look at another example. To create an entry code for a door lock, you need to first choose a letter and then choose 3 single-digit numbers. How many different entry codes can you create? Okay, so first thing, just a little bit of information, because a lot of the problems you're going to do are going to deal with letters and digits. There are 26 letters in the alphabet, A through Z. Whenever it says single-digit number, we are thinking of 0 through 9. So 0 counts, which means you have 10 possibilities. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 would be 10 numbers you can pick from. We want to know how many codes are possible. We have 4 blanks to fill here. We have 1 letter, and then we have 3 numbers. So 26 letters in the alphabet, and we've got 10 possible single-digit numbers, again, 0 through 9. What would be easier, a tree diagram or multiplication? Definitely multiplication in this case, because you can see with 26 letters in the alphabet, that is going to be a crazy tree diagram. That's going to just be so confusing to look at. So the counting principle by using multiplication would be easier. And I would just say because the tree diagram would have too many branches, it would be really hard to count. Way too many branches. So let's set this up. Again, if you like the fill in the blank style, I'm going to set up the fill in the blank style. With these problems, you got to make sure you go back and read things more than once, because they sometimes will list a lot of stuff. You got to be able to pick out what you're trying to find. How many letters did they say? They said first choose a letter. So I'm going to do a red blank for letter and just label that letter. And then they told me I want 3 single-digit numbers. So I need 3 blanks. I'm going to put them in blue. All 3 of these are going to be numbers. And according to the multiplication principle, we're going to multiply all of our options together. So how many letters do I have to pick from? Well, there's 26 letters in the alphabet. So I can fill that first spot with 26 options. You're only going to pick 1, but you're listing how many possibilities you have. You're not going to use more than 1 letter, but you have 26 to pick from. Now I go to the numbers. For the first number, it could be 0 through 9. So I have 10 options for the first space. Nothing in the problem says that you cannot use a number again. So if it does not mention that repeats aren't allowed, you can assume that you can use a number all over again. So I still have the numbers 0 through 9 available for the second blank. I have 10 options for the second blank. And for that third blue blank, again, I have 10 options to pick from, 0 through 9. Nothing says I can't reuse a number in the problem. So now I multiply them together. 26 times, I see 10 times 10 times 10, so 10 to the power of 3. So I'm just going to really multiply it in my calculator as 26 times 10 times 10 times 10. So 26,000, or you could type it in 26,000, or I'm sorry, 26 times 10 to the power of 3. Same answer. Depends if you want to use the exponent or not. So that's how many codes you could create. I think now it's a little more obvious why we wouldn't have wanted to make a tree diagram. You would have had 26,000 branches. It's a good summer activity if you're looking for something to do in your time off. Just kidding. Okay. A couple more examples. I'll do 2, and then I'll have you try a few out. Let's say your debit card has a 4-digit PIN number between 0 and 9. We want to know how many different PIN numbers you could pick from. Okay, so everything in this problem has to do with numbers, no letters. So 0 through 9 means we have 10 options to pick from. You always want to look at how many blanks you're trying to fill. It said 4-digit PIN number. So I have 1, 2, 3, 4 blanks that I'm trying to fill. Each of them needs to be a number from 0 through 9. Notice the problem did not say anything about not reusing numbers, so we can assume that maybe these 4 numbers are all the same. Nothing prevents that from happening. Well, we have 10 options for the first space, 10 numbers that are possible for the second space, 10 numbers that are possible for the third space, and 10 numbers that are possible for the fourth space. 10 times 10 times 10 times 10 would be 10 to the 4th. You could type it in your calculator either way. I'm going to do 10 to the 4th to make it a little shorter. So I got 10,000 possible PIN numbers that could be created. It's a lot. You could also type in 10 times 10 times 10 times 10 and give you the same answer. Okay, next one, a little bit more information. You are thinking about your locker combination. Okay, it consists of 3 numbers between 0 and 49. So since we have 0 included, that's 50 options. How many different locker combinations are there? You have 3 spaces to fill. All of them are numbers between 0 and 49. Okay, for the first number, we got 50 options. If it was just 1 through 49, I'd have 49 options, but you got to include that digit 0 also. That's where the 50th option is coming from. Nothing said we can't repeat numbers. Oh, yes, it did. Oh, I need to read. Assume numbers can't be used twice. Okay, game changer. So let's say that we used the number 2. That means when we go to the second space, the number 2 is now off limits. So instead of having 50 options, now we only have 49 numbers left to pick from because we already used one up in the first blank. Go to your third blank. Now you have 2 numbers that are off limit. You cannot reuse the first space, and you cannot reuse the second space because it said they cannot be used twice. So now you have 2 numbers that are not allowed to be used. That leaves you with 48 options that are left. So my final answer here, how many locker combos can I use? 50 times 49 times 48. You're going to get really big numbers for a lot of these problems. 117,600 combos. And that would make sense because if there's a lot of students at school, you don't want anybody to have the same combination. So lots of combos. Okay, what I want you to do is try these out on your own. Okay, if you need to take some time and think about them, definitely do that. And then once you feel like you have an answer, you want to check your work, hit the play button, and I will go through how to solve these 3 problems. Okay, number 3. How many passwords could you make that consist of 2 letters? So I'm going to put those in red. Letter, letter, followed by 3 numbers. Number, and if it doesn't specify, it means you're allowed to pick anything 0 through 9. Number, number. If letters and numbers cannot be repeated. So this is kind of like the last problem we did where everything's going to have to go down in size as you move from left to right. So how many letters can we pick for the first blank? Well, we haven't used any up yet. So we got all 26 letters of the alphabet we could use. For the second space, though, since we cannot repeat a letter, now I only have 25 options left for my second letter. Going on to the blue spaces for numbers, my first number can be anything 0 through 9. So that's 10 options. When I go to the second blue blank, since I've already used a number up, now I only have 9 options left. When I go to my third blank, I've already used 2 numbers up, so I only have 8 options left. So I'm just going to multiply straight across. 26 times 25 times 10 times 9 times 8. A lot of this math is pretty basic multiplication. The part that you're going to have to spend more time thinking about is how to set up the fill in the blanks. The math, your calculator can pretty much do all of it. 468,000. Passwords. Okay. Next one. How many different possible ways could you answer a 10-question true-false test if you guessed on each question, which I would not encourage you to do at school. But let's just say, hypothetically, we wanted to know, what are your chances of actually getting all of those questions right? You're going to see it's pretty slim. So I have 10 blanks to fill because there's 10 questions. And this one you could probably do without the blanks, but I'll write it out. And I'm multiplying all these together because of the counting principle. Make sure I got 10 blanks. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, I got 10. It's a true-false test, which means you only have 2 possible answers for every question. It's either true or it's false. So every single one of these blanks only has 1 option or 2 options, true or false. I'm just going to put an arrow. Pattern continues. So you can kind of see what's going to go on each blank. It's just going to be the number 2. You're guessing on every question, so there's only 2 options to pick from for all these blanks. You could type in 2 times 2 times 2 times 2 10 times, but that's just 2 to the power of 10. So that's how I'm going to type it into the calculator. So there are 1,024 ways that you could answer that test. And when we start talking about probability, we'll look at a problem like this and see what's the actual probability, or what are the chances that you were to get 100% on the test. Well, you'll see that it's not very likely. If there's 1,024 ways to answer that test and only one of those gets you 100%, not in your favor to guess. So take away from this problem, study for your quizzes and tests in your classes. Okay, last one. How many different sunglass combinations could you make if you had 4 different types of lenses and 2 types of frames? Okay, so I see 2 categories, lenses, and I'll do frames in blue, times frames. I want to be able to pick 1 lens and 1 frame. All I got to do is multiply the amount I have in each category. I got 4 lenses to pick from. I've got 2 types of frames to pick from. Multiplying those together gives me a total of 8 possible sunglass combinations. Okay, and that's it. You can get started on the homework. Make sure you read the problems more than once. Read them at least twice to make sure you you look for keywords like cannot repeat a number, cannot repeat a letter. Things like that are going to influence what you put on the blanks. Okay, happy mathing.